Assalamu alaikum, gentlemen. Welcome to our series. This is third video which we are recording for the students of Physics 101 at YIC. This is experiment number 2 according to our lab manual. Its main title is going to be given to you equilibrium of forces. Equilibrium of forces. So, this experiment is having the objectives, or after this experiment you will be able to verify the resultant law of two forces and its direction formula. The second objective for this experiment, you are going to verify the sign law of forces. In bracket we have a given, this is also called the Lommy's theory. So, here you have, gentlemen, this law of Pyelogram, the rule, the principle which you are using in this experiment is called the law of Pyelogram. This law is showing you the two forces A and B that are converted to the pyelogram. So, trigonometrical identities or trigonometrical functions are used to calculate the resultant of these two forces A and B, which is shown to you here. After mathematical calculations or trigonometric formulations we have, because we have used the right angle triangle formula for solving this, the resultant magnitude of resultant vector is square root of a square plus b square plus 2ab cosine theta, and its direction formula, the angle alpha which is mentioning in this picture, you can see its formula alpha equals tangent inverse b sine theta divided by a plus b cosine theta. So, these two values you are going to calculate. And then second objective we have mentioned, it is a Lommy's theory or law of sines. So, law of sines, it is formulated a over sine phi equals b over sine gamma equals r dash over sine theta. And this picture is showing you the practical formulation of this experiment, where you have a force, b force, and the resultant vector r dash is going to be downward, and this circle is going to be mentioned by the graduated disc or the protractor we are using in this experiment. So, I am just going to show you through this. The apparatus used in this experiment, number one, it is adhesive magnetic board, then round dynamometer. Keep in mind, this dynamometer is going to measure the force or the weight directly, and I will show you the least count for this will be 0.1, which will be shown to you. So, gentlemen, this is the practical picture, or the diagram which you are going to make on the apparatus, which you are going to formulate or just perform on the apparatus. So, this picture, keep in mind, you have to follow this picture. Gentlemen, this is the picture, this is the observation table. You can see this observation table has two parts, the experimental and the theoretical. So, the beauty of this experiment we are just giving to you, that first you are going to measure this resultant and its resultant angle, the magnitude resultant and its angle alpha. You are going to measure experimentally by using this experiment. Then the same value you will calculate by using the formula of R and alpha, and then the last 3 columns are shown to you. These last 3 columns are the Lommy's theory or law of signs, which you are going to verify in this experiment. As I mentioned to you that in theoretical part you have to use these 2 formulas. This is for the magnitude of the resultant vector, square root a square plus b square plus 2ab cosine theta, and for alpha tangent inverse b sin theta over a plus b cosine theta. So, this you will use in the calculation. After calculation, you have to write the result, which is the best one, which you are going to find through the calculations as well as through the experiment. So, the one result you are going to write theoretical and experimental, its magnitude and then its angle which is given to you. This you can see resultant formulas are mentioned to you. Then Lommy's theory. This is the Lommy's theory which is given to you. If the ratios of all these are nearly equal, then you can see that Lommy's theory is verified. So, gentlemen, this is the theoretical background for this experiment. Now, I will move to show you the apparatus, then we will start the experiment. Okay, gentlemen. So, here we have the apparatus which we are using in this experiment. This board is shown to you. This is the adhesive magnetic board, and then these 2 pulleys which are given to you. These 2 are frictionless pulleys which move very easily to balance the forces, and then we have given you this thread at which ends you are going to hang the weights. This I am just showing you. This is the dynamometer, round dynamometer. In this you can see this thread just overlap this, and then you can see its 0 is here. So, if it is not exactly on the 0, you can just readjust by using this small screw to readjust this, and then you can fix this at 0. Keep in mind, this is showing you the dynamometer. You can see here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, small lines are there. So, we can say the least count for this instrument is 0.1 Newton. So, this is measuring the weight directly or the force which you are using in this. So, you can see by hanging this, I can see the exact force or weight of this body which is hanged in this hook to measure very accurately. Or you can see if I am increasing its mass, I can have a more accurate reading for this. So, by using this we can measure the weights or the forces very accurately. After this, I am going to show you the graduated disc. As I told you, we have two types of graduated discs with us in this lab. So, this first one I am showing you starting with 0, then 10, 20, 30, 40. So, this goes up to 360 because this is a complete circle. Graduated disc is complete circle. So, this has a total 360 degrees, and then the least count for this experiment, this has a 10 parts. So, each one line is 1 degree. So, we can say that least count of this graduated disc is 1 degree. Then I have another this graduated disc. So, in this 0 is vertically I have shown you here, then 10, 20, 30, 40. So, this one is showing you 0 to 90 degrees. So, each one quarter is for the 90 degrees. So, this has a 4 quarters and this has 1, 2, 3, 4, 5 lines. Each one line is 2 degrees. That means the least count for this graduated disc is 2 degrees. So, you have to be very careful in lab activity. What is given to you, you have to follow according to that graduated disc. Yes, gentlemen, so we are just going to start our experiment. Keep in mind this thread is given to you and you have to hang this thread over the pulleys, and then as I told you, you have to hang the weights. So, this before hanging you have to measure its weight. As I have mentioned to you, the least count for this dynamometer is 0.1. So, I am using 2 weights, A, then B and then R dash. So, for A I am just going to measure the weight. This is going to be 0.7 newtons, and then I have same weight B, and then I have R dash. Keep in mind R dash is more than A and B. So, these two I am just going to measure by using this dynamometer. So, this is near about 1 Newton, So, R dash will be greater than A and B. So, the two weights of same I have started 0.7, and then R dash at the center. Keep in mind this should be more than these two A and B. So, I have two weights, you can see 1 Newton, 0.7, A 0.7, B 0.7, but this R dash is going to be 1 Newton. So, hanging this at the center, this is the resultant R dash.
Can you put it on the second hook on top?
Yes. So, you have to pass through this frictionless pulleys. And then you have to balance this, as we have given you this. So, you can have this picture as we have mentioned to you in the diagram. So, by moving this frictionless pulleys, you have to form the parallelogram which you are going to get through this experiment. So, gentlemen, you can see in the picture the same is observed over here, and we have this R dash, A, B, R dash. Now, what you have to do? You are going to measure the angles. So, first of all, fix this at the center. So, the origin of this knot is going to be fixed with this, and 0 is vertically upward, x axis are mentioned over here. So, you can just see this. After this, you have to measure the angles and fill the table. So, in table you can see the starting angle is alpha, then you have theta, and then gamma and phi. So, I am going to start the first angle alpha. Keep in mind this 0 is vertically at center is mentioned to you. So, the 0 is at center, 0 to this right hand side A angle you have measured, this will be called the alpha. Then from this thread A to thread B, this will be called the angle theta. So, you will measure, already you have a measured alpha over here 51, then 10, 20, 30, 40, 50, and then you will add both of them to have theta angle. Then you have third angle, this is called the gamma, starting with this A thread to this R dash. So, this you are going to measure 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130. So, this way you have the angle gamma, and from R dash to this thread B will be the angle phi. So, I am just measuring 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130. So, this is phi. Now, gentlemen, be careful how to verify that you have measured accurately. This theta plus this gamma plus this phi. So, the sum of theta, gamma and phi, three angles must be 360 degrees. Error is allowed up to 2 degrees plus or minus. So, you have to be very careful. In experiment or during experiment, you can verify that you have performed the correct result. So, this way, one way you are measuring this, another way which I just shown to you. So, I am fixing this gentlemen, keep in mind, for second or another method, alpha is used in the same way, 0 at center, and then you can see this alpha, same way as we have measured in first method. But for theta, I am coinciding or matching this center with 0. So, this is another method to measure the theta, gamma and phi. So, now from this 0 to this thread B, this will be called the angle theta. This will be called the angle theta. So, 10, 20, 30, 40, 50, 60, 70, 80, 90 and then 100. This is theta. Then 0 which is coinciding with, or this is matching with this A. I am starting this towards this R dash. This will be called the gamma angle. So, this is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130. So, this way you have the angle phi, and then from this R dash thread to the B, thread B is giving you the phi angle. So I am going to measure this. This is starting with near about 7, then 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, and then this is 1, 2, 3, 4, 5, 5 plus 7, 12. So this is total is giving you the phi angle, and again you will measure this angle plus this angle plus this angle. This should be 360 degrees. So this is another way to measure the angle. So gentlemen, you have 3 different weights. The 2A and B, in first we have taken same, R dash is different. In second reading you can change the weights, means little bit different. So 0.5 I have added in this, and here I am just going to add some more, and then R dash is added over here, and then now gentlemen you can see this is 0.5 plus this 0.2. So this will be 1.2, and this will be 0.5 plus 0.2, this will be 0.9, and then R dash 0.5 plus 0.5 plus 0.5, 1.5. So all 3 have a different weights. Now you have to move this to get your equilibrium point. So wherever you are getting the equilibrium, then you will measure the angles by doing the same procedure. So gentlemen, you have to measure. Gentlemen, here I am just going to use another graduated disc which I have shown you, because in lab we have 2 different types. First one which I have shown you, this was having least count of 1, this one is having least count of 2. So I have increased weights, or I will increase some more weight in this. So you can see the shape is changed. So different weights can be added into A, B and R dash. So this way you are going to at least 3 to 4 different weights reading in your table, and then you will observe the experimental value for this experiment. Gentlemen, as I mentioned to you that first you will measure the resultant and alpha experimentally, and then you will measure by using the same data of A and B, and the angle theta you will measure theoretically. So the result, experimental and theoretical, they should coincide each other. Small error or small variation is allowed, but big variation is counted as error. So you have your proof or your experiment, that experimentally you worked out and found the resultant force, its magnitude and its angle, resultant angle, and then the same way you are going to calculate through formula that will be called the theoretical calculation, and this will be the proof of your experiment. So gentlemen, this is the experiment. So you have 2 results, experimental and theoretical, to verify them. Resultant law of forces by equilibrium and find their direction, and in the last we have mentioned the Lommy's theory. So if the ratios of sides to opposite their angles are equal, then you can write that Lommy's theory is verified. So gentlemen, this is the experiment. Thank you.